Hello, wonderful 2A students. So we are diving into our next unit. It's going to be a great way for us to build on what we just did. And the very first topic is solving systems by graphing. Okay, and so we're going to look at a couple different things so far, but the biggest thing is, why is the intersection the solution? So when we talk about a system, we're talking about two equations with two variables. The solution to a system is an ordered pair x, y that plugs in nicely to both equations. In other words, when you plug it in, it works out just fine. So in a second here, we're going to go through some special cases of systems. So before we do that, though, just want to run through that there's lots of different ways to solve systems. We can find the solution by graphing, which is what we're going to talk about below, by substitution, which is what we're going to talk about next week, and by elimination. Those are our three processes. So it gives you a little bit of a preview of what's coming. But special cases of systems. So I'm going to give you an equation here. Y equals 2/3 x plus 1 and 4x plus 2y equals 18. So the first equation, y equals 2/3 x plus 1, I can graph it. I've got a slope of 2/3, a y-intercept of 1, and I can generate some points, rise 2, run 3, rise 2, run 3. Can also work backwards to finish off the graph, but I can draw on a ton of points. And I can graph that line. The next one, let me solve it for y like we did last chapter. By getting y alone, subtracting 4x to start, and then dividing everything by 2, and getting y equals negative 2x plus 9. And the reason I care about the negative 2x plus 9 is that now I have a slope and a y-intercept like we had last chapter, and we can sketch that graph. Okay, so there is this graph. Now this pair of equations is called consistent, independent, because it has one solution. And that one solution is 3, 3. Okay. Now, that'd be great if we had lots of cases like that, but we won't. We're going to have some times where we see something different. So the first thing we might see is this. Here's a cute little line. And then I graph the next line. And they both line up perfectly on top of each other. That is called infinitely many solutions, because the two lines are exactly the same and they sit right on top of each other. That's called consistent, dependent. We have one more. So we've got one solution, we've got infinitely many solutions, and then we'll finish with no solutions. No solutions looks like this. I have my first line. And I've got another line. And these lines are parallel, which means they have the same slope, if you remember back to last chapter. And these are called inconsistent. Okay. The majority of the work we do in this particular chapter, and as we get working through solutions, is going to be on one solution problems. So don't stress too much about the rest of that vocab. Focus on that one solution. Focus on finding that ordered pair that is your answer. Focus on crushing this unit.